Alright, so here we are again. Quick little intro to the Routing and Switching version 5 rack control panel within the rack rentals section of ine.com. As you see here, I have device management section. We're going to be using 10 different routers and 4 switches for our topology. We've also loaded an initial configuration of BGP full. As you can see here, there's a lot of options we can start up with for our initial configs. Now, a lot of these initial configs have to do with the workbooks. If we come over here to our workbooks, we can open up, say, where is it? BGP Labs. So I open up the BGP lab here. We start out with establishing iBGP peerings. It'll give us certain tasks to do, and we can expand if we want to view the configuration to see if we did it right or wrong. One of the first things we will do here is configure router 1 to router 8 using AS100. So here's router 1. Router 8's over here, so it's an iBGP peering over the existing network. Let's see if we can get that to work once my rack starts. So we're also creating a full mesh of iBGP peerings between these devices without using their loopback 0 interfaces. Advertise the loopback 0 prefixes from these devices into BGP. Ensure full IP version 4 reachability for loopback 0 prefixes 1 through 8. Oh, it's BGP 1 through 8. A full mesh of peering. You must load the initial configuration files for the section named Initial BGP, which can be found in the RS version 5 topologies diagram and initial configurations. We'll reference the Advanced Technology Labs, so let's click on this to see what that one says. Looks pretty much like our topology now, doesn't it? Alright, so let's go back one. This will be our task when we start. Establishing an iBGP peering. We have about 6 minutes left on this. And the cool thing about INE, sometimes they give certain specials where you get tokens with subscriptions, which is the reason why I have 620. But the Routing and Switching version 5 rack rental is about 5 tokens per hour, which is what I currently have scheduled. The nice thing too, you can also extend the current session, but the button extends it by 3 hours, so you can't extend it by, say, 1 more. Alright. Okay. I wonder if there's an initial BGP on here. I guess we can search for it. Initial BGP. There's a base. Let's do the initial BGP. I'll stick with BGP full. See how that comes out. I wonder if that's already going to do all the config for us, though. This is the first time I'm using the rack rentals. I'm really just playing with it and testing it out. Doing this recording for kind of I guess my own purposes, and put on my Legion training site here on YouTube, so hopefully anyone going to be watching this will get a kick out of looking at 10 virtual routers and 4 virtual switches all connected together. Now, some of my other videos you'll see are on Viral. Viral is kind of the emulator that I put together. But I really like this rack rental too because they're pretty much real devices and not emulated or simulated in the viral. So, alright, I'm going to give us a few minutes. I'm going to pause the recording and we can start up again as soon as it starts. I'm wondering, how do I pause? I can stop, annotate, tools, toolbars. I guess there is no real option for pause, so I'll be back here in about 4 minutes. See you in a minute. Alright, so you'll see here we started back up. I'm on 59 minutes as I got the hour. Hopefully my config set. So one of the cool things about INE, you can come over here and you can click on the device. You can show the configuration of said device, which you kind of have to wait for it. That kind of sucks, but okay. Wow, it took a long time. VRF definition management do not change. Interesting. Spanning tree, gigs 1, and nothing's configured. Well, apparently that didn't work, so I'll try this BGP full again, load the config. Okay. They said it will take about another 4 minutes, so I'll bring us back online when we're ready to go. Now it's finished loading. We were supposed to be able to come over here and click on the device and use it, but I'm guessing that's not working. Alright, so one of the other ways for us to get into these devices is go to rax.ine.com and log in as the username. And as you see here, we telnet into some kind of console server, which is pretty BA. So we'll log in here to router 1. Let's scroll back down. Let's see my topology here. Alright. Kind of odd that it's not working, but oh, I guess I had to hit the escape character. So now we're in user mode, so we'll enable. Let me do a show run here, and wow, it just ran through it, didn't it? Wow, that's just insane. Let me see if I can change my settings in PuTTY to make it a little better for everybody. What do we think? 18? Ooh, that's a little much. Maybe 16? It's good enough, I guess. Well, show run, question mark, everything in here. View. Gosh, it keeps doing that. Show run, section, VGP. Okay, so we actually have all of our neighbors in here already. Show IP interface. Brief. The tunnel 0 interface. Show run interface tunnel 0. It's running IP NHRP. Multicasting, it's using a PIPA addressing, which is also interesting. Okay. Show IP interface brief again. Show CDP neighbors. Well, we're connected to all of these devices. Let's try detail. So I'm connected to, Yeah, that's terrible. It just sends it all the way to the bottom. Wow. Oh, CSR 1000V. Oh, that's cool. They're all virtual. So 192.168. 192.168. It's Ethernet 2. Let's try to ping that. Well, yeah, that'd be nice if it wasn't administratively down. So gig 2, I'm guessing, is kind of a management interface. I wonder if this is running in viral or something like viral. Anyway, so tunnel 0 is 155.1.0.1, so I'm guessing the 169 addressing is a fake WAN. Yeah, it kind of seems like it. 169.254.100.9. 3? Well, 3 works. Let's try to ping over the tunnel. Okay, well the tunnel to router 2 doesn't work. We did the BGP full. I'm wondering if 2 is just not in the cloud. Show DMVPN. Okay, we are connected to 2. Oh, now it works. I guess I just had to kind of wait for it, huh? Alright, show IPBGP. That's, of course, the BGP route table. Show IPBGP summary. Shows us our neighbors' prefixes, etc. Show run section BGP again. As you see, it's already doing our network statements and our neighbor statements, and it's doing the IBGP peer group. That's cool. Because over here in our establishing IBGP peerings, we're supposed to configure router 1 through 8 in AS100, create a full mesh, which is interesting. I went over here and looked at the configuration, cheated a little bit. 1.58.8 is not what they have. Interesting. I wonder if there's a mix miss they have here. So show IP route. Okay, we have all of our ERGRP routes, our BGP routes. So the 151.1.1, what is that? Not run. 150.1.1.1. Okay, that's the loopback. Which I guess I could have noticed that from the mask. /32, yeah. Alright, so those are the loopbacks. We're learning the loopbacks via ERGRP. So let's see here. Router 8. Let's try to ping that. That didn't work. 155.1.58.8. You need to have a space. Oh, well, that pings. Alright. So do show run section BGP. Router BGP 100, of course, because we're doing IBGP. Neighbor 155.1.58.8. Pair group IBGP peers. Alright. Do show IPBGP peers. Oh, peers. Neighbors. Neighbros, man. Alright. Holy crap. Okay. Do show IPBGP summary. Neighbor 58.8 active reset. Peer closed the session. Well, that's of course because I haven't created that. Unicast topology base removed from session. Interesting. Alright, show IP route 155.1.58.8. We're learning it from 155.1.146, so do show IP interface brief for the 146 network? 146.1. I wonder if I have to make that appear on 8. Alright, well, let's see how it goes when we exit all the way out. If it's going to kill our session, or hopefully dump us back into the console server and we can look at 8 on 146. Dump me back into R1. Huh. Okay, well, let's take a look here and see. Rack rentals, routing switching version 5. Let's look at the rack rental guide. Accessing routers and switches using a telnet connection. Must the return key a few times to get the prompt. I guess I didn't read that, right? For each device, you must make an additional telnet session to the gateway. You cannot break into the rack main menu after you have telnetted to a switch. Well, guess I kind of learned that in a trial by fire, huh? Okay. So, oh yeah, it said we should be able to go to the control panel and click on the device and open a telnet console from here. So let's see if refreshing that fixes it. It doesn't seem to. It'd be nice if I could just connect to this guy. Okay. So let's make another session. Let me take this up. I'm going to try using the appearance at 0.14 right now to see how that looks. It'll probably look a little less bold, but RS5 rack 23 Rusian. Alright, let's connect to 8. Enable, show run, include BGP, show run, include source. Update source loopback 0. Well, router 1 is using peer groups. Router 8 is not. Okay. So So is that show IP interface brief, AT, router BGP 100, neighbor 155.1.146.1, remote AS 100 because it's an IBGP. Yeah. Interesting. Okay. Update source gig. 1.146. Of course. No. 58. 58.8. That's source of 1.58. Let's try the same thing over here. Do shall run section BGP. Neighbor. So the peer group isn't going to work then because let's update source. So let's try this again. Update source gig 1.146. No, duh. Gotta specify the remote autonomous system first. And the neighbor's up. So yeah, that's one of the things about BGP as well. It is a TCP session, so you really have to be able to provide TCP communication, and we needed to make sure the update sources kind of on a one-to-one basis. So we do show IPBGP. Do show IPBGP. Oh, do show IPBGP. Do show IPBGP summary. That's why I wanted summary. So you're going to see here now that we have the 58.8 and the 8.8. Because when we looked at the section BGP, you notice we had the peer group. So pretty much everything was using the loopback 0 as its source. And if that loopback 0 isn't the destination over here on 8, it's not going to work, apparently. So I'm so surprised I can't come in here and click on the router. Maybe I missed something else. I'm going to go back to the rack rental guide. Accessing the routers and switches using the control panel. Yeah, I should have just an open telnet option. Well, that doesn't seem to be working out, does it? Let me refresh the page. Maybe something is messed up. Okay, device management. Okay, router 1. There's no telnet option. That makes me sad. Alright, so let's do the BGP. Was it initial? Initial BGP. So let's try that one. So it's going to take another 4 minutes to load. So let me pause the video for a sec, and we'll come back once it's done. Alright, so we reloaded up here. I have about 33 minutes, so we can come back into racks.ine.com. RS5, rack 23, Erosion. 1. Change my settings yet again. I'll do 14. Looks better for me anyway. Okay, let's see. See what changed. Show run section BGP. Nothing. Show IP interface brief. Everything comes up. Show run router. ERGRP. Odd. Show IP route. Okay, we have routes to our neighbors. Okay. So if you remember from our other lab guide, it wanted us to create a BGP session to router 8 on a non-loopback interface, which I'm guessing is G1-58. So config T, router BGP 100. We're going to advertise our loopback, which, of course, is a /32. Do the neighbors statement. Hopefully I remember 155.1.58.8. Remote AS 100. Now I kept the peer group in there, didn't I? So let's duplicate this session. RS5, rack 23, Erosion, switch 8, show IP interface brief, 58.8. According to the layer 3 interface, it's VLAN 58. Show IP route. I'm guessing gig 100, right? Okay. Do show IP route 155.58.8. 146. So it's this guy right here. 146.1. Yep, makes sense. Big T, router BGP 100, network 150.1.8.8, with a mask /24, neighbor 155.1.146.1, remote AS 100. To show IP BGP summary. Yeah, there's my neighbor. Do show IP BGP. I got the 150.1.1.1. We'll do a ping of 150.8.8.8. Unreachable. even though BGP found it, it says its next hop is 155.1.58.8 to show IP route 155.1.58.8. Interesting. To show IP route. I already did that. Alright. So it's redistributing via EIGRP. To show IP route 155.1.8.0/24. So this should work. If I'm able to ping the neighbor, do show run section BGP, do ping uh 155.158.8, right? 150.1.8.8. Okay, well, I can ping the neighbor. Do ping 150.1.8.8. Do show IP route 150.1.8.8. Yeah, it's running it through BGP. It's internal, so it's a distance of 200. I guess there's one thing else we could try. 155. Do show run section BGP. Neighbor 155.1.58.8. Update source gig 1.58. Do show IP interface brief. Oh yeah, right. Run router 1. 146. Same thing over here. Do show IP interface brief. This will be the 58 on router 8. Do show run section BGP. So we got the neighbor 155.1.146.1. Update source gig 1.58. Maybe this will work, maybe it won't. I might also have to flush BGP. Alright, clear IP BGP. Star. Clear IP BGP star. .155.1.146.1. Okay. Show IP route BGP. Ping 150.1.8.8. Still unreachable. Let's try a trace route. It gets to 146.4 and then of course doesn't know how to get there. Alright, 146.4. So what we're looking at here is 1 is going to 4. It looks like on the 146 interface, isn't it? Yeah, the 146. So because 4 doesn't know how to get there and 5 doesn't know how to get there, the packet just stops at 4. So 4 over here just says, I don't know what you're talking about. So let me put this in the right perspective. So 1, 8, RS5, rack 23, region 4, let's see, what are we trying to get to? So show IP route, one 150.1.8.8, subnet not in the table. So who's the next one we connect to? Router 5. Alright. This is one of the things you will never, ever, ever do in a CCIE lab. Create static IPs, but, you know, for now, we'll just figure it out. So, do show IP interface brief, 146. Make the next hop 155.1.146.4. Or 5 in this case for the router. So do show IP route 150.1.8.8. Okay. I don't think this is going to work. Hey, it did work. I don't know why the trace route failed. Kind of odd too. You got to wonder on 5, what is the source? So over here, show run section BGP 146.1. Show IP interface brief gig 1.146. So let's do a ping source gig 1.146. And it works. Still wonder why the trace didn't work. Oh, there you have it. BGP convergence on CSR 1000Bs. Show IP route BGP. Notice here that 155.1.8.8. Same thing over here on router 4. Show IP route BGP. There's nothing there, of course. So show IP route 150.1.8.8. It's going to be a static to router 5. Now, router 5 somehow already knows how to get there. So on router 5, we shall say show IP route 155.1.8.0, but we're looking at 150. Interesting. So, the last resort, ping 150.1.8.8. So oddly enough, you got to kind of wonder. Let's see, what did this trace route to? 1.145. Well, that is the case. So somehow the 150.1.8.8 was able to traverse router 5, even though it doesn't know how to get to the loopback interface on router 8. I'm going to chalk it up to one of those things where we probably put in the wrong IP address. I think we did. 150.1.8.8. Yep, it gets to 5 and doesn't know what the heck to do. IP route 150.1.8.8 /32. Show IP interface brief. 155.1.58.5. 58.8. Do ping 58.8. Ping's just fine. So do ping 150.1.8.8. And that works. Go to ping 150.1.8.8. That's not going to work. Show run section BGP. Okay. Update source gigabit Ethernet 1.146. So let's see if we know how to get to that interface. Ping 155.1.146.1, and it does. Ping 155.1.146.1, and it does. 150.1.8.8. Do show run. No, not do. Show IP route static. Ping 155.1.146.5. Maybe I was just hopeful. I was just hopeful. And that really didn't work for me, did it? Do show runs include route. No IP route, blah, blah, blah. Do show IP interface brief. It's connected via 45, so we can try that. 45.5. Okay, do ping 150.1.8.8. Hey, it works now. Ping 150.1.8.8. And there we go. So, one of the things you don't want to do in a production environment is screw around like this, because, like I just showed you, I fat-fingered the 155.1.8.8 instead of the 150.1.8.8. But you'll see here now that because each router knows how to get to the loopback of router 8, and we have ourselves a source interface of gig 146, which everyone knows how to get to that interface, but they don't know how to get to the loopback. So we do 150.1.1.1, not in the table because we haven't advertised the loopback address. So 155.1.146.1, and it's known via ERGRP. So like I said before, there's a lot of getting used to in this. Routes have to match up. You know, we really didn't do a great job at this because router 4 and router 5 are not BGP peered, with router 1. But you'll also know that if we wanted to peer router 5 to router 1, we would need to know how to get to its loopback. So if we show run section ERGRP, you'll see here that the loopback's not in the network either. So if we came in here to router ERGRP 100 and did a network of 150.1.1.1, we'll go over here to router 8. We'll see if this showed up. And it did. You can see here that it shows up in the routing table. Same thing over here, show IP route 150.1.1.1. So, show run, include route, no IP route. Same thing over here, show run, include route, no IP route. And we took those routes out. Think it's going to work? Doesn't work. Okay. Show run section BGP. Because the neighbor is on the gigabit Ethernet 158. Which, of course, once again, is the reason why it doesn't work. So, config T, router ERGRP 100, network 150.1.8.8. This, of course, will put everything in via ERGRP. Show IP route 150.1.8.8. You'll see here that it's learned via ERGRP 100. However, if we do a show IP BGP, we can put in the 150.1.8.8, and you'll notice that it is known by 155.1.58.8, which is the neighbor. And of course, we have a rib failure. Fantastic. Let's try to ping 155.1.58.8. Works. We already know that 150.1.8.8 does work as well. But one of the things you'll see here, if you show IP route, (155.1.8), 150.1.8.8 is a /32. So because they match, they're going to use the administrative distance by default. So if we come over here and config T, router BGP 100, let's see, distance, mm, 85. Source address. Okay. Do show run section BGP. Gigabit Ethernet 146. Apparently it doesn't work. We'll do the same thing we did before. Go to the source, right? 155.1.146.1. Wildcard. Enter. Okay, do show IP route 150.1.8.8. Still known via ERGRP. show IP route 150.1.8.8. So do clear IP BGP clear IP BGP 150.1.8.8. Maybe? No, that's not the neighbor. Alright. Show run section BGP. Do the same thing here, except our neighbor is 1.58.8. And now you'll see that the BGP peer comes back, and we have the correct route in BGP. One of the reasons you'll see this is because the longest batching bits will be the one that's used. Now, ERGRP and BGP both have a /32 mask, so the next thing they use is going to be the advertised distance. In the case we saw here, the show run section BGP, is we changed the BGP distances for external, internal, and local to lower than 90. And now because it's BGP 100 to BGP 100, it's an internal route. So we chose 80. Now once again, if you didn't see that before, we'll come in here to router BGP 100. We'll specify a distance for the BGP process. External AS, internal to the AS, and then of course local. So there you have it. That's a way for us to create IBGP relationships over an ERGRP, pretty much a multi-hop style network. So we went from 1 to 8, but we had to know how it traversed the network first. Now ERGRP routed it to 4. Now 4, of course, didn't know where to go, so we told it to go to 5, and then 5 didn't know where to go, so 5 told it 8. However, once we included the loopbacks into ERGRP, we were able to ping the loopbacks. The problem is we wanted BGP to be the route selection. So by changing the administrative distance of BGP to less than ERGRP's default of 90, then we were able to use BGP. Pretty neat, and yeah, it's always an interesting thing doing networking, especially in a lab environment when you don't really have a set goal in mind. What do we really want to provide for this? Is it really necessary to do that? Now, one of the nice things about what we just did is kind of a layer 3 VPN style. Now, we're not running MPLS, and we're not running Atom and all that stuff, but basically we created a tunnel between R1 and R8. So that IBGP session sees that these two guys are neighbors and really doesn't care about anything that's in between. So, alright, very cool. Well, if you're there, thanks for watching.